Hi guys, this video is the examples of how you're going to actually graph the functions. So we're going to go through this graphing process 3 times, and this is exactly how I want you to do it on your homework. Do not do what the book says. I want you to just break it down in these ways that I'm going to do. Okay? What the book says are these ways, but it doesn't say it very clearly, so it's all good. Alright, here goes nothing. Our first example is this one. I have x squared plus 2x minus 15 over x squared minus 9. There it is. Alright, so the first thing that you should always do is to factor the top and bottom. Okay, so hit pause for a second, see if you can factor the top and bottom, and then come back to me. Alright, I'm going to factor the top as x plus 5, x minus 3, and on the bottom x plus 3, x minus 3. Okay. Now the next thing you want to do is to go ahead and simplify this thing. So I see that there's a common factor. Do you remember what a common factor means? It means there's a whole. So this is x plus 5, x plus 3. Okay, so this common factor starts us off. I see one, I cross it out. This is the new rational function that I have to work with. I no longer need this one, okay? You're done with that. We already simplified it down to this. And so you don't have to go back to that one anymore. You can just use this one, okay? Now, I see that this is a whole because it had a common factor in the top and bottom. The whole is at 3. So, all I need is a y-coordinate to go with that 3. So I'm going to take my 3 and plug it back in here and find out what y is. So 3 plus 5 is 8, and 3 plus 3 is 6. 8 over 6 is 4/3. So my whole is at 3 4/3. Okay? The next thing that I want to look for are the vertical asymptotes. We've factored the denominator, and the vertical asymptote comes from the denominator, and so it is at -3. Horizontal asymptote is when you are looking at the first terms. I'm only looking at the x over x. X over x reduces down. This is a 1x and a 1x, so it reduces down to 1 over 1, which is 1. Okay. For the x-intercept, that's where y equals 0. So I would take my function and set it equal to 0 and solve. Do you remember how this always worked? When I multiplied by the denominator, this just becomes 0. This goes away and it equals the numerator, and then I solve. Nice. X-intercept is really just where the numerator equals 0, but that's why, because the denominator always cancels out, goes away. Okay. The y-intercept is where x equals 0. So I put 0 in here and I get 5. I put 0 in here, I get 3. So it's at 5/3. For the domain, the numbers that I was not allowed to use, and this is how Pearson has theirs when you type it in, so I'm going to write it this way. The domain is everything except 3 and -3. 3 causes a whole, -3 causes a vertical asymptote. So everything but 3 and -3. Okay? So these are the things that you need to find, and then you need to sketch a graph. I'm still trying to decide how we're going to get this graph thing to work. It'll be great, I'm sure. Alright. Alright, here we go. I'm going to put in a vertical asymptote at -3. Just put it in as a dotted line. Put in a horizontal asymptote at +1, just as a dotted line. Okay. Your x-intercept is -5, dotted in. I want to see those points. And the y-intercept at 5/3 is 1 2/3. The hole is at 3/4, so just above the line. 4/3 is 1 1/3. Okay, remember what's happening here? The curve was broken here, so I have a curve on this side, so you have to decide, is the curve above or below the horizontal asymptote? Well, this one looks like it's going to be below, so it's going to go through here, but it's going to hug the horizontal and hug the vertical. So it's a guideline to show you where the curve goes. There's going to be another curve over here. Is it going to be above or below? Well, this one looks above, so it's going to go through the point and hug the vertical, go through here and hug the horizontal. So I have my two curves because I have one vertical asymptote that cuts the graph one time. Okay, so I have all kinds of different little things to go find. I'm just doing little puzzle pieces, okay? But you got to remember where each piece comes from. So the vertical is from the denominator, the horizontal is from the first terms. X-intercept is where y equals 0, y-intercept is where x equals 0. Sorry, this one. The whole is from this common factor. Okay, we wrote all that down in the last video, and now we're just putting all the puzzle pieces together. Alright, we're going to do that 2 more times. I want you to pause any time that you need just a little bit more time to think it through before you watch me, okay? Think about me walking around the room, giving you a little bit more time to think it through. Here's the next one. I have x squared plus x minus 12 over x squared minus x minus 6. I want you to take a few minutes here without me. I want you to pause the video, factor it up, and reduce it if possible. If it reduces, it's because it has a hole. Go find all the pieces that you can remember how to find and then come back to me, okay? Alright, start by factoring. I'll see you back here. Alright, I'm going to factor x plus 4, x minus 3. On the bottom, it's x minus 3, x plus 2. So, I have a hole, which reduces this down to x plus 4, x plus 2. Since the hole is at 3, I gotta go put the 3 in here. So I have 3 plus 4 over 3 plus 2, which is 7/5. That's this. Okay. Now for the vertical asymptote, I look at the denominator. What makes the denominator 0? -2. For the horizontal asymptote, I look at the first terms. X over x becomes 1. The x-intercept is where y equals 0. Where y equals 0, the denominator cancels and goes away, and it's x plus 4 equals 0, so -4 equals x. The y-intercept is where x equals 0, so I have 0 plus 4, 0 plus 2. 4/2 is 2. For the domain, what numbers are not allowed in that denominator? 3 and -2. Okay, ready to sketch. Put all your puzzle pieces together. Hit pause any time so you can think it through by yourself before you watch me. Here goes nothing. Vertical asymptote, -2. Horizontal asymptote at 1. X-intercept at -4. Y-intercept at 2. And this one has a hole again here at 3 7/5, which is 1 2/5. Alright, I see I'm going to have 2 curves. On the left hand side, the curve is going to be below again. It's going to go through the point and approach the horizontal, approach the vertical. It's going to be above on this side, so it's going to approach the vertical, approach the horizontal. No, it looks suspiciously like the last one, doesn't it? I hate that. All right, that was a good one. I've got one more. This one has a little bit of a change to it. I hope that one went well for you. If not, back it up and try them again, okay? All right, on the last one, I have x plus 3 over x squared minus 4. We start by factoring and then looking for all your pieces. See if it'll reduce, okay? Hit pause here so that you can try doing this on your own first, and then we will come back together. Here goes. The numerator's fine, but the denominator factors. Difference of squares. I have no common factors, so this one is not going to reduce. We're going to work with this the whole way through. The vertical asymptote is where the denominator is 0. What numbers make that 0? -2 and 2. 2 of them. The horizontal asymptote, we look at the first terms. You know, it's easier to see the first terms here. They're already multiplied out. When you have x over x squared, it reduces to 1 over x. And remember the rule when x is really large, that it goes to 0. 1 over a million is 0. Okay. The x-intercept is where y equals 0. So I'm going to take my function. I need more room. Set it equal to 0. Remember how the denominator cancels out and goes away? It's really just the numerator we care about. So -3. The y-intercept is where x equals 0. You know what's easier to work with is just going back here. If I plug 0 in to the original function, easy to work with. So on the original function, I've got 3 and -4. -3/4. Isn't that a lot nicer? I don't want to go over here and plug it in if I don't have to. Both of these are the same thing, so if one works better for one and one works better for another, just go back and forth. It's okay. For the whole, did I have any common factors to cancel out? No. So no whole. The domain is what makes the denominator 0, and so x cannot equal -2 or 2. All right, we are ready to graph. Sometimes these with 2 vertical asymptotes are a little bit more mysterious than the others. So we may have to grab a calculator to help us out with this, okay? Let's check it out. The vertical at -2 and +2. The horizontal at 0. Okay, x-intercept at -3. The y is at -3/4. And that's all the information that we have. So this is not a lot of information. And so what we would like, there we go, stay. What we'd like to do is use our calculator to give us kind of an assist. So I'm going to take my calculator. That's fine. And look, I have it plugged in already. Hooray! Does that mean that's the one from our... Oh, that's why it looks familiar. All right. When I do this, I plug it in there and I can go look at the graph. Remember to do zoom standard. Zoom number 6 standard takes it back to a 10 by 10. Just as a help. All right, so we can see that it's coming down on the side over here. Did anybody else recognize that? I did not. I recorded the other one yesterday. I just totally forgot about this. All right, and on the bottom and along here, it's going to touch, bounce up, and keep on trucking. Okay. I think I had a sign difference in it. Oh. No, I just plotted it at the wrong spot. Ah, see, you guys would have yelled at me in class when I messed that up yesterday. Alright, so this is our last one. If we're having some more troubles, then maybe when we meet online at some point, if you need more examples, we can. But anyway, that's graphing rationals. Use your calculator. If we had been in class, we would have done a lot of memorizing and practicing and together and not had to use our calculator so much. We would have done a lot of mental math, but we're just going to get through this, folks. So grab that calculator and let it help you figure out where those curves are at, okay? It's more a matter of can you recognize where they're at. So that's that. I'll get you some more instructions about what kind of homework situation we've got going on. I'd like you to do the book problems. I think those are much more beneficial. And then I want to give you a couple of Pearson questions in each section just so that you can practice using the system. So I'm still trying to figure out how many problems of each I want to do. But probably you're just going to turn in even questions to me. So if you just want to work on evens, more power to you, out of the book. But you won't be able to check them. But, I mean, you know, if you feel okay about what you see on your calculator matching up to what your work shows, then that's okay. Otherwise, it'll probably just be a couple of problems off of the Pearson website so you can practice using that thing. I don't want you to fail the test because you haven't ever seen it in that form before, okay? All right, we will see you in a bit.